Okay, so here's topic C. If chords are perpendicular to a radius slash diameter, then the chord is bisected. So what's a chord? So a chord is a segment. It goes from one edge of the circle to the other edge. So it doesn't go through. It's the two endpoints are on the circle, and it goes from one end to the other end. So we're given that OM is equal to 4 units and AB is equal to 6 units. Well, this piece of information here is what we need. That chord is bisected by the radius. So this segment is equal to that segment. So if AB is 6, then half of 6 is 3. So each of those measures 3. We're also given, we're told to find AM. So we know what AM is. The measurement of AM is equal to 3. So the measurement of MB is also equal to 3. And the measurement of OB, we don't know what that is yet. So we can use Pythagorean theorem to find that. Students were also taught that there are Pythagorean triples. And that's a combination of 3 numbers that satisfy the Pythagorean theorem. I've only given 2 triplets. One is 3, 4, 5. The other one is 5, 12, 13. So if students remember that information, they could put down 5 and be done with this problem. If they forget that information, then they just have to use Pythagorean theorem. So I would say 3 squared plus 4 squared equals x squared. That's 9. 16 equals x squared. So I have x squared is equal to 25, and I could take the square root of both sides, and I get that x is equal to 5. So the measurement of OB is equal to 5. And I'm done with this problem. So students, it's important that you remember that if a chord is perpendicular to a radius or a diameter, then it bisects it. All right, so C2 says a circle with a radius of 15 centimeters has an 18 centimeter chord. How far is the chord from the center? So students want to spend time trying to understand what information you're looking for. It says how far is the chord from the center. They're talking about this distance. It's indicated by the blue line. So what am I given? I'm given that the chord is 18 centimeters long. So then this is 9, and that's 9 centimeters. I don't know what this is, but I am told what the radius is, which is 15. All right, so now I can use Pythagorean theorem again. So this is going to be x squared plus 9 squared equals 15 squared. X squared plus 81 equals 225. X squared is going to equal, I believe that's 144. Take the square root of both sides, and we get x equals positive 12. And that's the answer for C2. Students want to make sure that they're familiar with this diagram, because they're going to be given a problem in which they have to just read a statement and be able to create a diagram that looks similar to that one. Okay, C3, in a circle, a 40-inch chord is 15 inches from the center. So this is an example I just mentioned. So I'm given the circle, and I'm told that there's a chord. Okay, so what do I know? I know that the chord is 40 inches in length. So then that means that this is 20 inches and this is 20 inches. The chord is 15 inches from the center. So this is the center of the circle. So then that must be this distance right here. And I'm told that I need to find the radius. So when the chord and the radius cross, they bisect each other. Correction, the radius bisects the chord, but they're perpendicular, so it means that they form right angles. So then it makes sense to use the Pythagorean theorem. So this is my x. So I'm going to say 15 squared plus 12 squared equals x squared. 15 squared is 225. 20 squared is 400. So that gives me x squared equals 625. Take the square root of both sides. X equals plus positive 25. And I'm done with C3. Okay, C4, so this is a problem in which students are, let's see, we have to find X. So students will make a mistake of trying to multiply the two segments because that's what you do for some problems. But I don't know what this segment is, so that's why I can't take that approach. I do know that this segment is congruent to that segment because the chord bisects the diameter, or the diameter bisects the chord. So then what I would do is I would set this up as 5x minus 16 equals 3x minus 4. So now that's where the geometry stops, and then I got to go back to my algebra skills to solve this equation. Subtract 3x from both sides. So it's 2x minus 16 equals negative 4. Add 16 to both sides. 2x is equal to positive 12. So divide by 2, x equals positive 6. And I'm done with this problem. All right, this completes topic C.